In this video on the XYRIS instrument, we're going to look at the ability of the instrument to measure multiple components within the measurement plane. And the measurement plane is this large black area. And we're also going to look at the ability to control the resolution of the data we collect from the images. So those are the two key things that we're going to look at. You can see here the silver coin on the left and a copper coin on the right. We just reduce the image here, and we're now looking at the XYRIS software. And on the left here, we have the visual representation of the measurement plane. And as noted before, we have a measurement area up to 90 millimeters by 90 millimeters. And within that, we have undertaken two initial measurements of the coins at very low resolution, just to show you where the data is. Firstly, the copper coin, which I'm pointing to with the cross, is on the top right here, and the silver coin to the lower left here. So the first thing we're going to do is we're going to set up a measurement, and for this we're going to look at these data in the top left of the tab. So the first thing you can see is we have a measurement area here preset as 3 millimeters by 3 millimeters. And this corresponds to the area currently shown by the yellow box, which I'm pointing to here. I'm going to zoom in a bit so you can see that a bit closer. You can see that's centered over a tail of the image that's on the back of this coin. What we've chosen to do here is we're using a data resolution of, the number of grid points of 500, which gives you the number of points in X of 501, and the same for Y. So we have 501 by 501 data, which is giving us a grid spacing of 6 microns. This is going to be our first measurement. So we go to the automated measurement feature on the top right here. We click on that. And that is now identified as our first measurement. I'm also interested in a feature, this chain feature here. So I'm going to click on that. And I'm going to reduce the measurement area to 2 millimeters by 2 millimeters. That effectively, with the same number of data points, is reducing the grid spacing to 4 microns. So I'm going to add that to the measurement sequence, and that is now measurement number 2. I'm going to come across this penny, so another artifact and another part of the table. I'm going to click on, there's a cross here right at the top of the coin here, which I think is just about visible. I'm going to zoom into that so you can see it in a bit more detail. I'm going to reduce the measurement further to 1 by 1, so 1 millimeter by 1 millimeter. Our grid spacing for that feature is now 2 microns by 2 microns, as shown here. So I need to add that to the sequence of measurements. Before I need to do that, I need to adjust the Z-axis here, because actually there's a slight difference in height, which I know from the previous measurement. And you can see that is now within the measurement range for that particular measurement. And I'm going to add that. So that's number 3. So if I just zoom out again. So we have 3 measurements, different areas, 3 by 3, number 1, 2 by 2 for number 2, and 1 by 1 for measurement 3. And measurement 3 is at a different height position for the sensor, but that's already been included in the program, because we've set that up so that the sequence will run and the Z height will adjust according to the measurement that we've requested. So I'm going to start this measurement off just by clicking this. And now you can see that a measurement has started. First of all, we're doing the relatively large area measurement, and you can see the data being collected for measurement 1 in the view beneath. So you can see high resolution data here with the grid spacing. I think it was 6 microns. And we're going to let that measure. Measurement time for this particular measurement is 7 minutes. It's an automated program. So the 3 measurements here will probably take about 10 minutes to combine, but I can now walk away from the instrument, go and get myself a cup of coffee. Once the 3 measurements are completed, there'll be a noise which will alert me to the fact that the measurements have been completed. Or if I were to leave the room and go off to a meeting, it will send me an email to tell me that the measurements have been completed. As the last measurement reaches a conclusion, I'm just going to show you the camera view, which will make larger. You can see here the light spot from the sensor on the top of the copper coin. We have 22 seconds here to complete the final measurement. Let's reduce that down. And here we can see the data being collected from the 3rd measurement, and we know it's the 3rd measurement by looking at this screen here, and you can see the -3 to indicate the 3rd of the program measurements, and it's now completed. So that was the noise you heard for the completion. So we've now completed a program of measurements on the sample shown in the left-hand window here. You've got the first 3x3, the second 2x2, and the third on a different artifact, 1x1. And in each case, the number of data points, the grid spacings, the number of grid spacings were always 500, so 501 by 501 data points, which gives us, in the case of the 3rd area shown here, we can zoom into that a bit, and we can see the detail on there now. Just zooming in to the image, we can see quite a nice image of that cross feature, and that's got a 2-micron spacing. What we're now going to do is we're going to use the BEX software, which is shown in the window here on the top left. I've actually already preloaded the 1st and 2nd measurements into BEX. So I'm just going to share that screen now. So here we have the 1st measurement. So the 1st measurement was an area 3x3, and we can see a lot of data now on the surface. It's a sharp 3-pointed feature here on the top surface of the coin. We can also see that the surface of the coin is quite got quite a bit of roughness on it. We just change the color scale here. We can see from the color scale from the bottom. You probably see that a little bit more effectively just by bringing that, changing. And all we're doing here is we're just changing the color map. Of course, we've got cross-sectional information on this, so if we just show that, and maybe bring the line, let's bring the line down to here. Here you can see the roughness of the features going across the blue plane here. So the 2nd artifact we measured is shown here, and that was a chain-like feature. And again, we can have cross-sectional information. This is now 2x2. And if we just take a look, we have the cross-sectional information for the line here. So I'm just going to load in the 3rd point, which is this file here. Let that load. And here you can see the cross now within BEX, and you can see some detail of that feature.